Welcome. Today we are going to master a powerful tool for visualizing data, the histogram. By the end of this session, you will be able to draw and interpret histograms and understand exactly when and why we use frequency density instead of just frequency. We use histograms to represent continuous data that has been grouped into classes. While they might look like bar charts at first glance, there is a fundamental difference that we need to explore, especially when our groups aren't all the same size. To start, let us look at the difference between a standard bar chart and a histogram. In a bar chart, the height of the bar tells you the frequency. The categories are usually discrete, like your favorite color or the number of pets you have. In a histogram, the data is continuous, like height, weight, or time. The bars must touch because the data flows from one class to the next. But here is the most important rule for IGCSE. In a histogram, the area of the bar represents the frequency, not just the height. Why do we care about area instead of height? Imagine we are looking at the ages of people in a leisure center. Notice the third group. The first two groups have a width of 10 years, but the third group has a width of 20 years. If we just plotted frequency on the vertical axis, the third bar would look massive, giving a misleading impression that the 20 to 40 age group is the most dense or common, simply because the group is wider. To fix this distortion and compare groups fairly, we use frequency density. This adjusts the height of the bars so that the area correctly represents the number of people. To calculate the height of our bars, we use the frequency density formula. You must memorize this for your exams. The class width is simply the difference between the upper and lower boundaries of a group. Let us apply this to the data we saw previously. For the first group, the width is 10 minus 0, which is 10. 10 divided by 10 gives us a frequency density of 1. For the second group, 2010 is 10. 10 divided by 10 is also 1. For the third group, 4020 is 20. 20 divided by 20 is also 1. Notice how, even though the third group has a higher frequency, its density is the same as the others. This tells us that people are spread out just as thinly in that group as they are in the younger groups. Now, let us walk through a complete example of drawing a histogram from scratch. Suppose we have recorded the time in minutes that students spent on homework. Here is our data table showing the intervals and their frequencies. Step 1. Calculate the class width for each interval. For the first two intervals, the width is 5. For the third, 20 minus 10 is 10. For the last, 4020 is 20. Step 2. Calculate the frequency density by dividing frequency by class width. Let's perform the divisions. 5 divided by 5 is 1. 15 divided by 5 is 3. 25 divided by 10 is 245. And 10 divided by 20 is 0.5. Take a moment to check these values. We have heights of 1, 3, 2.5, and 0.5. These are the values we will plot on our vertical axis. In the next section, we will see how these densities determine the heights of the bars on our graph. Now, let's draw the histogram based on the frequency densities we just calculated. On the horizontal axis, we plot the time in minutes. On the vertical axis, we label it frequency density. It is a common mistake to label this axis just frequency, so be careful. We now plot each bar. Bar 1 goes from 0 to 5 with a height of 1. Bar 2 goes from 5 to 10 with a height of 3. Bar 3 spans 10 to 20 at 2.5, and bar 4 covers 20 to 40 with a height of 0.5. Observe the third bar. Even though it represents 25 students, it isn't the tallest bar because those students are spread over a 10-minute interval. The second bar is the tallest because it has the highest concentration or density of students within its 5-minute window. If we want to find the frequency from the graph, we simply calculate the area. The width is 10, the height is 2.5. 10 times 2.5 equals 25. The area gives us the frequency back. Finally, let's recap what we have covered to ensure you are ready for your IGCSE exams. Histograms are for continuous data. The vertical axis is always frequency density. The formula is frequency density equals frequency divided by class width. And most importantly, the area of the bar equals the frequency. You have learned that we use frequency density to avoid being misled by groups of different widths. This ensures that the visual bulk of the graph accurately represents the amount of data in each section. Here is your checklist for drawing. First, find the class widths. Second, calculate the frequency density for each group. Third, label your axes correctly, usually with time on the horizontal and frequency density on the vertical. Finally, draw touching bars with the correct heights. Whenever you see a histogram in an exam, Check the vertical axis first. If it says frequency density, remember, the answer is in the area. You are now equipped to draw and interpret these graphs with confidence. Well done!